Good morning students, how are you? I am Francis sir and today we are back after so very long holiday. Yes, I hope your Durga Puja holidays was well and so today we will start our fresh session with Standard 7 Physics lesson number 13. The measurement of time. This is the topic today that we have to discuss. So before we start discussing how to measure time, we should try to understand that what is time. Time can be considered to be as the difference between the instance of repetition of any periodic phenomenon. There are so many periodic phenomena in nature. For example, sunrise and sunset, it keeps on repeating itself after regular interval. Yes, then we have full moon to another full moon means the interval between one full moon to another full moon. It is almost of 28 days, and this is almost of 12 hours. And yes, from one season to another season, if we are talking about of one season to another, it may take about 3 to 4 months. Or if we are talking about the same season, it will come back again after 365 days. So we can understand that this time is the interval between any two different physical phenomena that is happening in regular intervals. Okay, so this is your time. So we do not take these as our standard. We do not take these all as standard time. Why? Because these all are quite long. But as we can see that these time intervals are quite large, therefore they cannot be used as standard time. Understood? So since they are large, if we want to measure small instant of time. For example, a person running 100 meter sprint. If we want to measure that time, it cannot be measured by using so much big time intervals. Okay, for that we need to have a smaller unit. So, in search of smaller units, later on, as the requirement started. This led to the invention of some devices that could measure small time. So people, the people in olden days, they also felt the requirement of measuring time in a small time intervals they wanted to measure. So in that case, it led to the invention of some of the devices that could measure small time. The example was your sundial, sand clock, or we can say water clock also was there. Okay, so these were some of the devices which could measure small interval of time. Okay, but still these could not measure exactly the more small. We need as I told we can the smaller time interval unit we get, the more accurate reading we get of the time. So in that case, these all will also not so useful. So in that case, later on, scientists called Huygens. Huygens showed that the pendulum could be used to measure time, and this pendulum we will study later on. Okay, so this pendulum was a device which could measure time with small intervals. Okay, so when we will study the pendulum, we will discuss how it functions and what are the things related to it. But when this pendulum was the first device which could give us the measurement of small time. Okay. Now there are some of the specific units of time. These are, first one is 1 minute is equal to 60 seconds. This second is the smallest. The second is the smallest unit of time. Okay. So this minute is equal to 60 seconds. Then we have hour. Hour equals 60 minutes, and then we have 1 day, which is equal to 24 hours, and 1 month equal to 30 days. Okay, and then we have 1 year, which is equal to 365 days, or we can say 12 months also. Okay, so these are some of the units which are from small to big, which these have been taken as the modern units of time. So we should try to understand what this day is actually. The day can be considered to be as the time taken by the Earth to complete one rotation is known as one day. Okay. So when one rotation completes, it has been taken that when we divide this one day into a certain amount of divisions, when we divide this into a certain amount of divisions, then what happens is that we can consider to be as 1 second. This rotation has been only, this interval of this rotation has been only divided into this how many parts? This rotation, one rotation time has been divided into 24 into 60 into 60 times, and this is the one which is equal to your 1 second. This 1 second equals 1 day. That means this one rotation, that which is completed, it being divided by 24 into 60 into 60. Yes, this is actually the measurement of 1 second. Okay, this is only the measurement of 1 second. This is called solar second, or it is called, this reading is called solar second. Why do we call it solar second? Because we try to understand this rotation with the help of what? Sun. If I am facing the sun now, and when I rotate in this way, next time again when I come to face sun again, that is called one rotation. So this time interval is related to sun, therefore it is called solar second also. So this 1 second can be considered to be as one rotation period divided by 24 into 60 into 60. Okay. Now, similarly, we have 1 year. 1 year can be considered to as time taken by the Earth to complete one revolution. It is called 1 year. So this is the time interval of 1 year. Okay. So now we will study pendulum. So here we have pendulum. Okay. So what is a pendulum? Pendulum is a device, which is a setup in which we have a fixed support on which is there a massless string and a ball, which is a heavy object, it is in contact with this massless, not contact, it's attached to this massless string. So what happens is that if we take this ball to a position this time and at this place, and then it is released, what happens? It will show an oscillatory movement. This you might have seen. Yes? Okay. So what happens is that the time interval for this ball to move from here to here, and this extreme position to this extreme position and back to its original position, it is called one oscillation. Time taken for the ball to move from its main position to one extreme position, then from extreme position to another extreme position and back to its original position. This is called one oscillation, and it has been noted that the time taken for this oscillation is 1 second. Okay, so this device, if the time taken for this oscillation is 1 second, this could be used as a watch clock. This can be used as a watch clock. So in this way, the pendulum could also be used for measurement of time. But it is not always that it's always the time taken for one oscillation is 1 second. It is not always that. Sometimes it does vary. Sometimes time taken for one oscillation, it can be different. So since the time taken can be different, we give it a name. It is called the time period. What is called time period? Time period. Time taken for one oscillation for a particular pendulum is called its time period. Now it can be that there might be certain number of oscillations, certain number of oscillations that occur in 1 second. The number of oscillations that occur in 1 second is called its frequency. It is called frequency. For example, there is a relation between these. There is a relation. The relation is that if let there be 20 oscillations, occur in 1 second. How much? In 1 second. So this 20 oscillation is called frequency. Okay. Now, what will be the time taken for one oscillation? For one oscillation, the time taken will be 1 by 20 seconds. Very easy geometry method. So, and as we know that the time taken for one oscillation is called time period. This is your what? Time period. This is your time period and this is your frequency. So there is a relation that frequency is equal to 1 by t, or t is equal to 1 by f. T is equal to 1 by f. So this is the relation between time period and frequency. So these are two of the terms. One is your frequency. This is one term frequency, and another term is your this time period. Another one is time period. Time period is what? Time taken for one oscillation is called the time period, and what is frequency? The number of oscillations that occur in 1 second. This is called your oscillation. There is one more thing. The one more thing is that here the displacement of the ball. The displacement of the ball from its mean position to its extreme point. This is the extreme point, not the maximum displacement of the ball from its mean point. It is called amplitude. What it is called? Amplitude. One more term here comes, amplitude. Amplitude is equal to the maximum displacement of the ball from its mean position. is called amplitude. Amplitude can be considered to as the maximum displacement of the bob. Bob is what? This heavy object present, it is called bob, where it moves from this mean position to its extreme position. You know, this maximum displacement, distance from here to here, this is called your amplitude. Okay, so there are some numerical problems also related to this. We will discuss that in the next class. Okay, with this I and this video, with this I and this video, I'll see you in the next one. Okay.